Oh man. Oops. Um, okay. So the next question that we have on the menu here is, what is the derivative of tan x? It's really asking for us to do d over dx of tan of x. Now I'll tell you straight up that this is something that you might want to memorize to be equal to secant squared of x, which is equal to 1 divided by cos squared x. Now let me show you why this works. So we know that tan of x is equal to sine x over cosine x. It's a little bit complicated to like fully give you a detailed proof as to why this works, but just trust me. Sine is equal to, tan of x is equal to sine divided by cos. Okay, so if we were to take the derivative of d over dx of tan of x, that is equal to d over dx of sine over cos. Oops. We got to hit this with the quotient rule. Hit it with the quotient rule because when you have one function divided by another function and you're taking the product of that and the derivative, or you're taking the derivative of the product of that, you have to hit it with the quotient rule, which is d over dx of f of x over g of x is equal to the derivative of the top times the natural bottom, subtract the natural top multiplied with the derivative of the bottom, all over the bottom squared. So given the quotient rule, let's run our function through this. So it is equal to the derivative of the top is sine x. So, or the derivative of sine x is cos x multiplied by the natural bottom, so that's also cos x, minus the natural top, so that's sine x, multiplied with the derivative of the bottom, which the derivative of cos x is negative sine x. Don't forget that negative. So since we're going to multiply negative sine x on this, we can just make that a positive. So plus sine x over the bottom squared. So that's cos of x squared. So let's rewrite this, like instead of writing cos times cos, we can just have cos squared. Same with the sine. Sometimes instead of writing it like the whole thing in brackets and then squared, you'll see this. This means that like the coses are squared. But stay ready for both notations. Of cos x. Now, an important thing that I want to mention is that 1 is equal to cos squared of x plus sine squared of x. That's a super important trigonomic identity that you most likely want to memorize, because this is very useful in a lot of different situations where you want to simplify things. So we can just replace the entire top with 1, because the cos squared x plus sine squared x, those added together, that's 1, over cos squared of x, which is equal to secant squared of x. And that is how we came to the conclusion of this being the derivative of tan x. So generally, you're probably going to want to memorize the derivative of tan x instead of like going through this entire quotient rule process every time. But otherwise, that's that. Isn't that fun? Derivative of tan x is secant squared of x. We just need a comment in the answer. Secant squared of x is written, should say derivative of equals secant squared of x. Or I'll write it this way: d over dx of tan x is secant squared of x. But otherwise, the answer follows the similar pattern of we got to use the quotient, or first we're going to break down tan into sine divided by cos. Send it through the quotient rule. Hit it with the identity on the top. Looks pretty good, but I'm worried about that because those are not equal. So I'm going to mark this as incorrect.